Hi, in this video I will be talking about resistors connected in series. As a start, I will be explaining what does resistors connected in series mean, or how we can tell that these two or three or many resistors are connected in series. As you can see in this circuit, I have three resistors, R1, R2, and R3. Now, every single resistor will have two ends. So if I'm drawing my first resistor here, you can see let's call it R1. That's an end, and that's the other end. If I bring another resistor and I call it R2, also it will have two ends. Now, if I join these two ends here together, so it's end to produce this way to be, that's R1, and that's our little junction here connecting the two ends, or each end from each resistor. That's what we call it a resistors in series. So these two resistors are connected in series. So in our circuit here, I have this end from R1 connected with the other end from R2, the other end of R2 connected with one end from R3 directly. That's what we call resistors connected in series. Now, the other thing, I have my battery here providing me with a potential difference. The current will be going through the circuit in one track. So the same current will be traveling through R1 to R2 to R3, all through all three resistors, and come back to the battery. So looking at this connections as series, the current will be going in one track, in one path. So the current will be, if I say the I total, or the maximum current will be generated by this battery will be equal the same current through the resistor 1, and it is the same current going through resistor 2, and will be the same current going through resistor 3. That's one of the advantages we need to learn about resistors in series. The current through all the resistors connected in series will be the same. However, for the voltage through this circuit will be a bit different. So if I say I want to erase this. So let's take these resistors away so we can draw. Now, what's happening in this case? The voltage will be shared between these three resistors. So that will be V1, that will be another voltage V2, and another part of the total voltage. So the resistors connected in series, in another word, it is a voltage divider. So it will be dividing or sharing the voltage through all these resistors connected in series. But the total of all the voltages will bring me back to the total voltage of my battery. So I can say here that the voltage of the battery will be shared between the three resistors, where it is V1 plus V2 plus V3. So each resistor will take part of the battery voltage to run the resistance or the resistor or that device. Now, all these formulas will be related, or let's say, who's deciding which resistor will be taking more voltage than the other one? Well, based on the Ohm's law, V equal the current multiplies with the resistance. Now we know for sure that the current is a constant value. It will be the same as we said before. The current will be going through all these three resistors will be the same. So the relationship between the voltage and the resistance is a proportional relationship. If I have a bigger resistance, that's mean that resistor will take more voltage than compared to any others. So that's one of the key things can help us during solving some calculation problems. I can predict, or I can guess that this resistor will take more voltage than any other resistors because they are connected in series and it has a higher resistance, so it will take bigger voltage. Okay, now one of the main things we need to learn about resistors in series is how we can simplify our circuit to make it as a very simple circuit or ohmic circuit. So I will have one battery with one resistor. So I'm shrinking all these resistors, the three of them, and try to replace them with one equivalent to three of them. And that's what we call the R equivalent. And some people might call it R total. And it's very simple how we can find the R equivalent in series. It is R1 plus R2 plus R3. And it doesn't matter how many resistors connected in series, you just add them up and the total represent that equivalent resistance. Okay? And by that, you will have a very simple circuit. It have one resistor, we call it the R equivalent or R total, and one battery. Okay? So these are the main things you need to know about resistors in series. So we might be able to solve a very quick example here. I have this circuit. It's connected together in series. I have three resistors, 2 ohm, 3 ohm, 5 ohm. Now they shared the voltage coming from the battery, it's 10 volt, and the way they shared it, it is 2 volt, 3 volt, 5 volt. Okay, and the total current, it says it is 1 ampere. Okay, we could do so many things to confirm that. So as a first, I can say, all right, how about find what is the R equivalent? So R equivalent will be R1 plus R2 plus R3. So 2 plus 3 plus 5, that will give me 10 ohm total resistor. Okay, now second thing I can do is finding the total current going through this circuit, which is V over R equivalent. I have a 10 volt and I have a 10 R equivalent ohm. That will give me 1 ampere, which is what the diagram showing me. Here we go. Now let's make sure that is it really true each resistor have these voltages. I can confirm that. Let's see how we do that. Following Ohm's law, V1, it is the current on one through one, sorry, times R1. Now the current through the first resistor, it is the same current going, the total current. So it is 1 times 2, and that will give me 2 volt. For the second one, V2, again, I2 or I total, up to you, 1 times 3, that will give me 3 volt. And for the third resistance, it is 1 times 5, that will give me 5 volt. You can see here that's the 3 voltages, how they've been shared between the 3 resistors, giving me back my 10 volt, which is the voltage of the battery. That's one. And we said the bigger the resistor or the resistance of that resistor, the more voltage will take. And that's confirming again that the third resistance have 5 ohm. The third resistor have 5 ohm resistance. It's taking half of the total voltage of the battery. Okay, so I hope this video be useful to you, learning what does resistors in series mean, the main idea of it and the characteristic, the properties of it, that the current will be the same, the voltage will be shared, and we need to simplify our circuit to find R equivalent. In other examples or other videos, we'll be solving more complicated circuits to practice that. See you.